Don't we have to wait for someone to get back from the porch or wherever? No? Okay.
Did we have to reboot the computer again? Is there something that we need to do again? Is there something happening? I don't, what's
wherever? No? Okay.
Did we have to reboot the computer again? Is there something that we need to do again? Is there something happening? I don't, what's
wherever? No.
Hello, I got a computer plugged into a computer. Did you like that?
I hated it.
Me twice. That's my audio computer. It just happened to be, happened to be plugged in there. I was looking at the YouTube page. Hey, YouTube chat room. How are you doing? Hello, chat room out there. We're here to start a show. We have no Justin. We are going to start the show now. Are you ready for this? Are you ready for the show? We're ready for the show. Ready in 3, 2, 1. This is TWIS. This Week in Science, episode number 677, recorded on Wednesday, June 27th, 2018. Oh, say, can you see the science? Hey everyone, I am Dr. Kiki, and tonight on This Week in Science, we are going to fill your heads with a stellarator, rat tickler, and polio. But first...
Disclaimer, disclaimer, disclaimer. As we approach the anniversary of independence in what some call the greatest country, it is important to remember to look back and forward. It is also important to address what's going on in the present, of course, but let's keep it in perspective. The United States is a nation of immigrants, a nation of freedom, a nation of mutual respect, and of newfound friends. This nation helped humankind explore the deepest reaches of the oceans, as well as the outer limits of our solar system. But none of that would be possible without the inclusion of all people who ever wondered. Whether they were newcomers to our land, those that were here before us, or even people who were once not considered people themselves. Whether they were men, women, black, brown, familiar, unfamiliar, or something we had never seen before, progress depended and will continue to depend on everyone near, far, similar, different, human, mouse, or even extraterrestrial. Science, technology, and the continuation of life on this planet is for and by every one of us. So let's hear what newfound knowledge we all now share on This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
And the good science to you too, Blair. And no Justin. No Justin disclaiming today. That was a wonderful disclaimer, Blair. Thank you for bringing us into the show as we head toward the American Day of Independence next week. We're heading in that direction. We're just, getting a little American-y here.
Just for a moment. Just
for a moment.
It's over. We're done.
It's over, but we're here for the science. We are here. Justin's probably sleeping. I don't know what he's doing, but he's not here this evening, unfortunately, so we will not hear his dulcet vocal tones this evening. My cats are going insane right now, and I don't know what is going on. They're doing acrobatics around me, so I'm sorry if I seem a little bit distracted. They are distracting. Cats, they have got parasites.
Oh, no.
No, they don't. Okay, time for the science. We are here to talk all about lovely scientific things. I brought polio. I also brought news about a stellarator and some other fantastic news about life or parasites before life. Fun things. Blair, what did you bring?
Oh, I brought a story about why it's very important in a business partnership to speak the same language. I also brought the before mentioned rat tickling. I brought This Week in World Robot Domination and some wolf DNA.
Ooh, Wolfie. You like your DNA? Let's talk about it. And as we jump into the show, I would like to remind everyone that if you have not yet subscribed to our program, you can do so on iTunes, in the Google Podcast portal, all the great places, Stitcher, Spreaker, TuneIn. You can also subscribe to us on YouTube and Facebook, all these wonderful places where videos and podcasts are found. And you can find us by searching for This Week in Science. Or you can just visit TWIS.org for information. All right, into the science. Let's dive right in, everyone. Poliovirus. Right? I'm not going to tell you a story about it making a comeback. I've got some good news related to polio. Poliovirus is one of the viruses that is being investigated by scientists as a way to infect cells with a either genetic target or to use the aspects of the virus to stimulate the immune system to have some kind of response. Poliovirus especially gets into the nervous system, which is very hard to get past, especially if you want to get into the brain and past the blood-brain barrier. Poliovirus is really good at doing this. And so researchers in North Carolina at Duke University have published their study in Science Translational Medicine. They are publishing the inner workings of a therapy. Oh, how did this happen?
Oh, no.
Yeah, they have published the inner workings of a therapy that uses poliovirus to treat gliomas. And gliomas are brain cancers that are incurable. Senator John McCain has a glioblastoma. And the life expectancy, once you have a diagnosis, is fairly limited. So anything that can extend your life expectancy is good news. And so now publishing, I that's what I got confused about was the different articles. Back in 2017, the Duke researchers published in Science Translational Medicine the early ideas of this therapy to be able to treat it. To be able to treat glioblastoma using poliovirus. And now the researchers are publishing in the New England Journal of Medicine on their results, human trials using a recombinant poliovirus. And what that means is that they manipulated it. They engineered the virus to not be infectious and to still have results they wanted and to treat patients with glioblastoma and extend their lifespans. So what they have done is they've created a polio rhinovirus. Rhinovirus, that gives you the common cold, right? Infects you in your nose. They have combined the genomes of these viruses together, making a chimera, and they call it PVSRIPO, PVSRIPO. And it recognizes the poliovirus receptor within the immune system, CD155. This is widely expressed in cells of solid tumors and in major components of the tumor microenvironment, according to their paper. The study evaluated 7 different doses of this treatment, and also in a dose escalation phase and dose expansion phase. And they looked at these patients from May 2012 through May 2017. 61 patients enrolled in this study, and they have moved forward from a phase 1 trial to this, which is just safety, to this phase 2 dose expansion to be able to figure out exactly what the really safe dose is and how far they can push this treatment. And what they found is overall, Survival among the patients reached a plateau of 21% at 24 months that was sustained at 36 months. And this is actually good news. So patients who received the immunotherapy, their survival was higher at 24 and 36 months than historical controls, people who had had poliovirus and not gotten the immunotherapy. So to go, the usual life expectancy with the malignant glioma is usually less than 20 months. And patients that have it come back again, so say they use chemotherapy and other drugs and surgical removal of the tumor and get rid of it for a while, if they have recurrence of the tumor, they usually survive then less than 12 months. And so there have been advances in surgery and radiation therapies, chemotherapy, other targeted agents, but there's never been consistent improvement in survival rates or in the time of survival. And so this study expands that, extends lifespan for many individuals, and for people, where it really works, it seems to work incredibly well.
That's
and
great.
seems to work for recurrent tumors as well. So one particular patient, they were able to give this treatment, and after they had a tumor, and it caused the tumor, the immune system gets into it, and it caused the tumor to shrink and basically go away. And when it came back again, they just gave the patient another dose, and it worked again. So life expectancy was much improved.
So this is
exciting news.
This is thinking, hey, so what made polio so terrible? Well, it's pervasive. It can cross the blood-brain barrier, right?
Yeah.
It can go everywhere really fast, really thoroughly. How can we use that to our advantage?
Yeah, exactly. How can we? And we are. So it is the wonderful thing is that it overcomes the blood-brain barrier, which other therapies are unable to do. It also by targeting the poliovirus receptor, it actually triggers the body's natural immune response. And like I said, for people where it works really well, it's because it actually creates an antigen that the body remembers, so that the body's immune system attacks the tumor to reduce the tumor, where normally it ignores it.
That's really insult to injury for polio. It's like, hey, we completely eradicated you. Now we're going to use the husk of your existence to help keep us alive longer. I love it.
Yeah, I don't care about insulting polio. Let's do that.
It's good work. It's good, important work.
That's right. So, I mean, the strategy here I find wonderful. And so this use of what are normally infectious mechanisms that cause disease, to use the mechanism to our advantage to fight disease, I think is such a brilliant methodology. It has so much promise. And this is a very exciting result for people.
Yeah, you don't always have to kind of reinvent the wheel here. You can say, just like when we were talking about sperm delivering drugs, like, what is a really good swimmer? Oh, I know. So look at what already exists in nature, because nature did a pretty good job of R&D with a lot of things. So if you can key into that, there's stuff already there. It's pretty cool.
It's very cool. So yeah, let's use that polio to our advantage, and let's hopefully extend the life expectancy and quality of life for people with glioblastomas. Let's kick the gliomas' butts. Let's do it.
Please.
Yeah. In other news, last week I reported on the National Ignition Facility and its advances in laser ignited fusion. They're not there yet, basically, but they're step by step iterating, as we talked about last week. Well, another type of fusion effort is underway using tokamaks. And tokamaks are normally very regularly shaped, like kind of donut shaped devices that use magnetic fields to contain a hot plasma. And within that hot plasma, the hope is that eventually the temperature will get hot enough for long enough to create fusion. So far, we still haven't really created a fusion within a tokamak design that can create more power than we put in. It takes a lot of power to run these electromagnets that are containing the plasma and to heat the plasma itself. But there's a design which has come to the forefront in the last few years. Still not necessarily, it's not winning the fusion race yet, but in Germany, the Stellarator, it is otherwise known as the Wendelstein 7X Stellarator, and it also uses magnets to confine plasma and to heat the plasma up and to get it to sustain potential hydrogen atom fusion into helium. And what's interesting about the Stellarator, I find, is the shape. The Stellarator is like you took a donut and twisted it around on itself. It's kind of like a mix between a pretzel and a donut all in one. And the design is actually supposed to create a much more stable fusion environment, and it's supposed to be potentially much more efficient than the regularly shaped tokamak designs. So in 2015, this Stellarator, the Max Planck Institute for Plasma Physics, they for about 1/10 of a second could keep a plasma of helium ions. I cannot speak today. A plasma of helium ions heated to 1,000,000 degrees. Well, a couple years back, they upped it a bit more. They were able to get that helium up to 40 million degrees in the most recent tests. And so they're feeding in more energy also, but they've also made some shifts to make it a little bit more efficient. And the cool thing is that in addition to the 40 million degrees, they're also maintaining this for a much longer period of time. So this writhing mass of plasma is actually sitting around long enough to potentially do some interesting stuff. So there's a number of things happening on the fusion front right now that are very exciting. But yet again, this is but an iteration. It is not the giant step forward to power producing fusion that we're hoping for. But the Wendelstein 7X is promising, and the results are suggesting we may get there one day. And maybe it won't be laser fusion, maybe it'll be Stellarator. And I just love the name Stellarator. I can't help it. Yes.
You should change your cat's name to Stellarator.
I should, right? I named her Stella after, the word for star, but yeah. Stellarator. That's right.
You're like with laser beams.
That's right. She's not just a star. She's also a fusion producing twisty donut.
Yeah, sure.
Yeah. So the containment time, a couple of years back, they had gotten it up to about 6 seconds of plasma generation. Now it's at 25 seconds.
Oh, heavens.
Oh my gosh, it's almost half a minute. Like, that is something tangible, right? This is a tangible period of time. We're not talking split seconds. We're talking almost half a minute of plasma maintenance. I mean, this is getting there. But someday, hopefully, it'll be long-term generation for hours and hours and hours that will produce all sorts of wonderful power for us. In the meantime, they need to keep doing some efficiency tweaks. And I'm going to share the picture of the inside of this Stellarator with you because it's just such an amazing design. The the design itself has all these little plates. Like they look like a little bit like wall plates for lights or for a plug, and they're irregularly shaped with lots of faces on them, and then they're all seated in a discontinuous fashion that's twisting and turning. And so you don't have a sphere or a circular tube on the inside for containing the plasma. It's almost teardrop shaped. And this allows the ions to bounce off the surfaces in a way that is more conducive to the plasma. Yeah, manages the flow of this twisty plasma donut pretzel.
Bizarre.
It's quite bizarre, actually. And I know I'm doing the description. I'm not doing the description as much justice as I could. So the link will be at our website, twis.org. And so you can peruse this article and the images of the interior and exterior of the Stellarator if you have not yet looked at them before. It's just the engineering that has gone into making it. And then also, this is definitely math driven. They want to create a plasma. How are they going to get the ions to flow in the most efficient way? And where you would think, just put it in a tube. Tubes
Just
are
put
nice.
it in a tube.
That's not the way it works. And so this is just the design of it is fascinating.
Wow.
Maybe we should get somebody from the Stellarator to come talk with us about why it's shaped that way.
Where is it? Can we go visit?
Germany. Let's
go. That sounds like a TWIS short.
Absolutely. Long trip, short video.
Yeah.
Yeah. Well, this is This Week in Science. And Blair, are we going to go right now into...
Yeah, I mean, we might as well.
We might as well, because we don't have a Justin for this interval. It's time for Blair's Animal Corner.
Loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair? I was waiting for it. I was like, oh, wait a second. That's not coming.
It's not going to be there.
I have perhaps one of my favorite stories of 2018 thus far. And it is about a case of good communication. So this is coming out of Duke University, and it's about some animals on coral reefs. Now, coral reefs, for those of you that have been to an aquarium and seen them, one of my favorite animals to visit are the cleaner shrimp. Cleaner shrimp are amazing for many reasons, but they're called cleaner shrimp because they set up, 3 to 5 of them, set up a particular area, a shop, if you will, in the coral reef as a cleaning station. And fish come by, blue tangs, parrotfish, and snappers, and then the shrimp will pick parasites and dead skin off of their mouth, gills, and scales. So they're cleaning off these fish. Why this is so intriguing is that blue tangs, parrotfish, and snapper eat shrimp. So as a cleaner shrimp, getting in the mouth
danger
of a natural predator seems like an odd choice. Similarly, seems odd for the blue tangs, parrotfish, and snappers not to eat the shrimp. So what is happening here? Duke University says it is all about truth in advertising. These dental hygienists of the reef, as the first author Eleanor Caves calls them, says that they actually have a particular signal that lets fish know they are willing and ready to clean. So the shrimp, instead of being poisonous or distasteful, they actually say, hey, I'm going to clean you, so please don't eat me. They know for a fact that there's nothing distasteful about these shrimp because in the lab, they chopped up cleaner shrimp and fed them to the reef fish, who ate it all happily. So,
yum. I'll eat it all.
The first step of this research was to put a GoPro in 10 different cleaning stations on coral reefs off of the Caribbean. And they left them there for many hours. They recorded and analyzed almost 200 encounters with 18 shrimp and 10 fish species. What they saw was that when a fish approached the cleaning station, they pulled up to the drive-through car wash, if you will, the shrimp waved their long antenna kind of back and forth, like if you're waving your hands in the air, like you just don't care, perhaps. These convey a willingness to clean. 80% of the time when they waved, they cleaned. So this was a truthful signal. This was a real signal they were giving to the fish. When the shrimp did not wave their antennae, they would not clean. Where this gets interesting is, so that explains why the fish know, okay, you're going to come clean me now. But why do the shrimp trust the fish? Why do the shrimp say, okay, I'll jump in this guy's mouth. He knows what's going on. Well, it looks like these fish turn dark before the shrimp even touch them. There is a meaningful color change in the fish's skin that is a physiological response that is a signal that they're ready to be cleaned and they're ready to not eat the shrimp.
Wow.
So this is what they observed in the wild. Then in the lab, they wanted to take this a step further, as researchers always do. They found that they could show cleaner shrimp images of fake fish, which were just kind of circles and shapes on an iPad screen, propped up against the tank. The shrimp acted like it was a real thing. They went up and tried to clean, but they were more likely to try to clean dark-colored shapes than light ones. So the dark coloration was meaningful to them there. So the shrimp advertised their services by waving their arms back and forth. And then the fish swims up and turns dark and goes, okay, come on in. Water's fine. I'm not going to eat you. So
that's fascinating. I mean, this is honest signaling between disparate species.
Yes, absolutely.
It's communication. Yeah.
So then the last step of this that Kiki's been showing is actually a side-by-side of the visual approximation of how things look to first was the fish and then the shrimp. So they were able to figure out, based on the physiology of the eyeballs of these animals, that the fish can definitely see the waving back and forth. That's totally visible. The other thing is the shrimp's vision is terrible and their color vision is pretty much non-existent, but they can still tell through these tests that shrimp can see a difference in light and dark on these fish scales.
So hence the dark color changing of the fish.
Yeah.
So the question is, I mean, we can come up with all sorts of evolutionary explanations for why this evolved, but what an interesting communication system that the fish become darker. They don't change their color. They become darker. And that corresponds to the gray scale of the shrimp vision. So the shrimp respond to that. The fish can definitely see the shrimp when the shrimp are waving. So it's like, if a shrimp's waving, a fish is going to be like, hey, I see you. I'm going to come over and eat you, or you're going to clean me.
Yeah. So yeah, that's, I think the tandem responses is the thing that really caught my eye.
Yeah.
and made me really excited for this story, is that it's not good enough for the shrimp to say, hey, I want to clean you. They have to know they're not going to get eaten.
Yeah.
So the fish had to side by side say, I want these shrimp to pick my parasites. I have to give them a good reason to come over here and not think that they're going to get eaten. Of course, it's not all that kind of stepwise decision, but that is kind of how evolution works, right? Is maybe less shrimp came over because they were wary of predators. And then there were certain fish that had this physiological response that then gave a cue, and then more shrimp and more fish were able to do this. The shrimp were better fed, the fish were better cleaned, and those animals survived and propagated, right? So you can see how this would be mutually beneficial and would work once it happened. But how did it happen the first time?
Yeah. And the question is, this is honest signaling, or you think it is. So how
Yeah.
often are there cheaters?
Right.
How often are there fish who darken their spots so that the shrimp doesn't run away and then eat the shrimp? How often are there shrimp who wave their little antennae and then scuttle off and go hide?
Yeah.
You know,
Yeah.
between
And then
both of them.
the thing that really cooks my noodles is that is this a conscious decision? Right? Because they know that the changing of color, at least for the fish, is not in response to physical stimuli because it happens before anything touches them. They see the waving from the shrimp and then they change color. So how is that process? I want to know what that process is. If seeing a waving sparks a hormone that changes their color, or if there's something going on deeper than that.
The fish is like, man, my gums hurt. I got a toothache.
I have tooth sweaters. I need that guy to come over here. My tartar is so full of tartar.
Yeah, just feeling my teeth. They feel really weird. I feel like I need to get a teeth cleaning.
So, yeah, I don't know. Perhaps we'll find out later exactly what is cueing this response. But
oh my goodness,
yeah, fish and shrimp, they have a lot going on. People think
love
animals like these
noodles.
They cook my noodles. They can't. People think they can't think. People think that there's no decision-making processes going on. People think that, they can't, fish don't have as complex feeling or kind of strategies going on. But things like this really complex communication system across species boundaries, so cool. So cool.
Yeah.
And then from that, let's please move to rat tickling.
Because who doesn't want to tickle a rat?
Yes.
I make a little rat giggle.
I'm pretty sure we've talked about this on the show a couple of times. This is a study out of Purdue University looking at the benefits of rat tickling. So
to the rat or to the person doing the tickling?
Great cue. I think it's the rats, but that includes then a benefit to all of science, which is why I brought this week. So this is the Department of Animal Sciences from Purdue University. This is also from the Purdue Center for Animal Welfare Science. Rat tickling could be a way to improve quality of life for laboratory rats and improve scientific research. So this project was looking at kind of longitudinal studies of rat behavior and rat welfare, mostly in labs, but also with pet rats, and looking at the benefit, if there were benefits, and what the benefits were of rat tickling. So rat tickling is not coochie 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 coo. That's what they call it because that's what it looks like to the untrained eye. But actually what they're doing is they make brisk dorsal contact around the animal's shoulder blades. So you can kind of think about that as like if you see two dogs fighting, they might scruff each other. It's almost like a scruffing motion. You're pinching them between the shoulder blades with your fingertips, and then you flip them over and pin them down. So that is like, it's akin to social play for rats. So what you're doing is you're rolling them over and pinning them quickly. So it looks like you're tickling their tummies, but you're not quite. You're actually just playing with them. So the brisk dorsal contact is not technically tickling, but it looks very similar. So there's a bunch of reasons why certain labs have started doing this. One is to get the lab personnel more comfortable handling rats. Another is to get the rats more comfortable being handled. But most of all, they're trying to create a lower stress environment for the rats, and they want them to express positive emotions. So if you think about it, we've talked before on the show, for example, about how lab mice, have been stored at the wrong temperature all this time, right?
Yeah.
And so they're actually in stress while they're being experimented on. Same thing goes for rats. If rats are unhappy and unhealthy and emotionally stressed, then that means that that could have some weirdo cascade effect on almost any experiment going on with these animals. If they have stress hormones coursing through their body, they're not going to respond to things the same way. So that also means that when they receive inoculations or they receive treatment, that could create stress that then confounds results of an experiment. So they want to make human contact in general, treatment options, and then also just the existence in a lab all more pleasant for rats, for the rats' well-being, for the kind of ethical reasons, but also to help with scientific findings. So these researchers measured the pleasure, they call it, from this quote-unquote tickling through monitored behavior and also through ultrasonic vocalizations. So through sensitive audio equipment, they could find rat vocalizations from anywhere from 22 kilohertz to 50 kilohertz. 22 are stressed or fearful. They make sounds. This is the sound they make when exposed to predators, when they're in pain, when they're fighting. Improper handling techniques can also lead to vocalizations at 22 kilohertz. But in rats at 50 kilohertz, those vocalizations are happy. These are the sounds that they emit when they play with each other, when they're given treats, and when they're engaging in tickling. Yes. So they found that through these proper techniques, on one side, you want to make sure they have a proper home or cage, appropriate bedding. There's no obstacles to what they call safe play. And then also this tickling bouts of 15 seconds at a time. So this could help. The research showed it does in fact make handling of rats easier. It improves how quickly rats approach a human and increases positive vocalizations. When they were given injections as part of a treatment group, there were less negative audible noises and more positive vocalizations before and after injections. They also tested this with pet store rats, and they found that pet rats that were tickled were easier to pick up, to hold, to restrain. They spent more time outside their huts, and they made more positive vocalizations. So
they're happier. I mean, rats are social animals. They're not, if they're being kept in a lab situation, potentially in cages by themselves, isolated, that's going to affect their stress levels substantially. And so even if you have to have the rats isolated, the human can go in and play with them and increase their, and so then the rats become, they're playing, they're happy.
Yeah, and this
crazy.
Hopefully will also help people figure out how to be responsible pet owners of rats. Rats are really popular pets. They can often be really great pets. But just like a dog needs a walk every day, maybe rats need some tickling.
All right, rat owners or potential rat owners out there, tickle your rats.
Tickle your rats.
And make them happy. It'll make you happy too. Most likely.
And additionally, now I'm guessing more and more laboratories will start posting positions for head rat tickler, which I can't wait to see. Oh yeah, I pipette, I clean out cages, I make rat food. Oh, and I tickle the rats.
I know I could do that job. Dog walker or rat tickler? I'll be a rat tickler. Thank you very much.
Yeah, so
good
fun.
So fun. Oh my goodness, I love it. All right, everybody. We have come to the end of the Animal Corner, and it is time for us to take a short break. We will be back with more This Week in Science. I've got parasites. Parasites? What? That's right. I got parasites in the second half of the show. We do hope that you will join us for more This Week in Science in just a few moments.
Can't explain things you've heard more than intuition. A line of reason shows the way. Yo, new conclusion. The methods of hypothesis and patience are the.
And we're off to the races, everyone. Thank you for joining us for this episode of This Week in Science. So wonderful to have you here with us right now in this very moment. This Week in Science is a listener-supported program. So how can you help support the ongoing production of This Week in Science? Well, let me tell you right now. One way is to subscribe. And if you have not yet subscribed, please head over to TWIS.org, where you will find a big orange subscribe button. It's really hard to miss once you get there. It's big, orange, and it says subscribe. You click on it and it gives you various options: Google Play's podcast portal, iTunes, or YouTube. You can subscribe to all three. Maybe you've got an Android device, an Apple device, and you like YouTube. Yes, you can subscribe to us all those different places. And you'll always have TWIS at the ready, everyone. Yes, you will. So click that subscribe button. Or if you know somebody who might appreciate this show, let them know that they can go there to easily access our subscription options at TWIS.org. Additionally, we have lots of merchandise that is available through our Zazzle store. So if you go to the main header bar at TWIS.org, click on the Zazzle store link, it will take you to zazzle.com/thisweekinscience, where you can go directly if you want to do that. And you will find things like coffee mugs and t-shirts and mouse pads. You want a phone cover for your smartphone? We've got those too. T-shirt doesn't work for you? Maybe you need a classy polo shirt? Oh yeah, we've got those too. And we have lumbar pillows to support your lower back for those evenings where you're at home sipping on what beverage of your choice and you're aching back from a long day of standing or doing whatever it is at work. Got it. You've got a mammoth from a previous Blair's Animal Corner calendar, the artwork on your lumbar pillow supporting your back. Yes, we can do that. We've got that. There are hats, there are tote bags for your groceries. You can wrap babies in This Week in Science gear. Oh, yes, you can. You can also wrap presents. See how I did that there? Find all sorts of items. A portion of the proceeds from any sale goes to support TWIS. So if you are interested in supporting TWIS by sharing your love of us with the world, you can do it that way. Head over to our Zazzle store. Also, we are supported by listener donations. So one way, click on the yellow donate button on the sidebar at TWIS.org. It says donate. It'll take you to a PayPal interface where you'll be able to donate whatever amount, any amount of your choosing to keep the show going. Or you can go to any of the episode pages, listen to the episode there, scroll through all of the show notes that we have. And when you get to the bottom of the page, there are some pink donation buttons. Each of those donation buttons will allow you to donate in a recurring fashion through PayPal, if you like PayPal. Also, you can head to the main header bar and click on the Patreon link. Patreon is a crowdfunding platform that we use. You can become a patron through Patreon at whatever level of support you choose. We have many levels from $1 a month to $1,000 a month. Choose your level of support. Some of them, I think, believe in us. Yes, you do. No, it's beginning at $10 a month. We will read your name in the credits at the end of the show as a thank you for your support, starting at $10 a month. That is about the cost of some kind of a frothy coffee beverage or a cookie even. Some cookies are more expensive than $2 a week. So that level of support to be thanked on the air, it's a bargain. And you get TWIS every week. Every week. That's right. So TWIS.org is where you find all of the links to these various resources for supporting TWIS, links to every episode, and links out to things like watching TWIS live and the chat room for Wednesday evenings. You guys, if you're here on Wednesday evening with us, thank you for being here. Thank you for joining us. And those of you who are listening in your cars right now, thank you for listening and taking us with you every day. all of you who are out there as part of our audience. We couldn't do this without you. We thank you. Absolutely thank you for your support.
Can't explain things you've heard more than intuition. A lot of reason shows the way to go.
And we're back. You're
Yes.
listening to This Week in Science.
Yeah, we're back. We have all sorts of This Week in Science goodness still to come. So many more amazing stories. But first, it is time for one of our favorite segments of the show. This Week in What Has Science Done for Me Lately? Something suddenly got very loud in my house. I think my husband must be watching a movie upstairs.
Ooh!
Either that or it was a car going by. And if it was a car, that's some speakers. Woo! I could hear it all the way down here in my bunker basement. Okay, but what has science done lately? Well, this week our letter comes from Minion Steve Coleman, who has quite a story. It's a saga, in his words, of how the collective publication of scientific and medical open access research has literally rescued me, medically, physically, and psychologically. But this evolving story isn't over just yet. Now, I've taken bits from from an involved article that he wrote for me that I will share with you now. More than 20 years ago, I started having medical issues where when I ate certain foods, I would begin to have severe cramping and an obvious immunological response. I sought the help from my medical plan practitioners, but they could offer no advice as to what this food intolerance was or even what could be causing it. I had been tested for food allergies, and all antigen samples tested negative for any food allergy. And the immunologists were done with me. Over time, this immune response both worsened in intensity, duration, and the number of foods I was able to eat without problems slowly dwindled over time. He has a very limited diet today. He was then diagnosed as having sarcoidosis, and this condition is usually the immune system's last-ditch effort to combat some hard-to-kill invading organism like tuberculosis. He says, I was serologically tested, CAT scanned, PET scanned, and finally biopsied on the operating table. The result? Yes, they confirmed I had sarcoidosis, but without attribution to any causative agent. They had no clue as to why. But the condition eventually passed on its own. The doctors never gave the cause any thought, but the food intolerance not only persisted, but continued to get worse. All was not lost because I could still think clearly, and I had science. Not just science, but a really deep passion for understanding everything around me. And I had the open access research available on the internet. I began by searching the internet for the same unique patterns of a seemingly diverse set of unrelated symptoms, matching them to the set of all known human diseases. That's a big set. And keeping notes, pulling research papers from across fields of the sciences using Google Scholar, Google Alerts, Wikipedia, Mendeley Desktop, and listening to podcasts like TWIV, TWIP, TWIM, and TWIS, which we're glad you listened to. And then in addition, the Immune podcast. I haven't heard that one, but that sounds good. Through doing the comparatives for each disease and through the long process of elimination, the list of possible causes kept growing smaller over time. The trail of evidence eventually led me systematically toward a certain set of helminth parasites. As it's well established that most all successfully stealthy parasites will directly retune their host's immune defenses in order to remain unseen for years, and my immune system was absolutely going crazy. This mystery disease is a subcutaneous parasitic disease called Dirofilaria. And despite it being called a pulmonary disease in the United States, there are 27 known species worldwide. One of them you might know, commonly termed the dog heartworm. And it's spread by arthropod vectors like mosquitoes or black flies and horse flies. I had personally been bitten by a horsefly this summer before all my troubles started. The CDC says this disease is not a problem, yet there is no viable clinical test to tell you if you even have it. To make things worse, the disease is said to be asymptomatic in humans. Absent any medically available test I could purchase, I instead purchased my own lab equipment. As I assessed it from descriptions in the various clinical case study publications, I got a 1,600 times magnification microscope, overkill for this, with a CCD camera, blank slides, materials, reagents, chemicals, and H&E stain, the suggested stain for visual microfilaria diagnostics. And microfilaria are the larval stage of these parasites they inhabit the blood. I set up shop in my home office, drew my own blood, prepared the slides, applied the stains. Bingo! There it is. And another, and another, and another. Now I have many photographs of the microfilaria from a disease that I cannot possibly have. This story is not over yet, and I'm not out of the woods. I have now seen the mugshot of my nemesis, and I have read up on what needs to be done. My goal is not just to survive this ordeal, but then also to do everything I can to correct the official protocol and push for a more compassionate approach to the diagnosis and treatment of potential victims of this disease.
Wow.
Yeah.
He just really scienced the heck out of that, didn't he?
Right? I'm going to just take control of my own medical diagnosis. And yes, where medical science has been failing him, he has gone ahead and made some discoveries. And he actually shared images from his own blood of these parasites. And I'm sitting here looking at them going, those are little worms. Those are little worms. Oh my gosh. He said that that's from his blood. So his next step is to reach out to his doctors again and show them the slides and his evidence and see where it may take him in terms of treatment. And Steve, we hope that you are able to get the treatment that you so deserve. And after many years of suffering, be able to once again enjoy a varied diet and not be limited by your disease.
Yeah, keep us posted. I want to hear what happens.
I'd love to know what happens in this ordeal, this saga, as you put it. And it is something that what I appreciate about this entire story is that, yes, now we do have open access research papers. More and more research is becoming available for the public to peruse and understand on their own. And you can buy your own lab equipment and create a laboratory in your garage, in your kitchen. You can become a biologist studying your own physiology, studying your own, studying a disease that you may or may not have. You know, there are so many applications to the open access of science around the world that are going to have so many positive effects for so many people. And this is just a wonderful example of that.
Yeah. Wow. Good work and good luck in the future. My goodness.
Absolutely. Yeah. So Noodles is asking what his background is. It's physics. He is a physicist. He works in a physics lab. But
speaking of parasites,
beyond that, yes, I'm going to jump into some other stuff. Thank you, Steve, for writing in. I would love to hear stories from other people. Help us keep this going. What has science done for you lately? Send me your story. It doesn't have to be long and involved. It can be brief. It can be a poem. It can be a song. I don't know if I'll sing it. I might sing it if you send me a song. But send it to Kirsten at thisweekinscience.com or leave me a message on our Facebook page, the This Week in Science Facebook page, and I will read your story to the rest of our audience and share it widely. We can all grow and learn from what's out there. Our experiences. And now, parasites. I'm going to talk about parasitic molecules. That doesn't even make sense, does it? We've seen evidence in chemistry previously that there are molecules that can self-assemble, where when they are certain compounds are put into particular solutions, they create regular structures that can be used for various reasons. Carbon nanotubes are an example of this, the self-assembly of these little tiny tubes made of carbon rings, right? But beyond just self-assembly within molecular structure, Dutch researchers have been studying a system of non-biological self-replicating molecules. So what does that mean? We think of life as self-replicating, right? Replication, it's one of the features of life, passing on your genes to the next generation, creating more copies of yourself and moving along. Well, and one of the reasons, viruses have been considered on the very edge of this is that they don't actually replicate themselves. They take advantage of biological mechanisms for replication to do their replicating, right? So many viruses are these cellular parasites taking advantage of what things that are living have figured out. So these researchers publishing in a paper this last week, they have made a discovery. They've studied a system that involves one kind of self-replicating molecule that assists the formation of another type of replicator, but then it becomes like a parasite. The second one is like a parasite and consumes the first replicator so that it can survive and do better. The researchers say it is very exciting to discover parallels between completely synthetic chemical replicators and rather advanced dynamics seen in current life. Our work shows that a phenomenon such as parasitism that is well established in current life can already occur even before the emergence of life. This also means that strategies to deal with parasitism had to be developed early on.
Just right out the gate.
Right out of the gate, right? So parasitism was something this is a chemical thing. This is using resources from another to enhance your own ability to survive or replicate. That's something that's been going on since the beginning, right? So these researchers were working on synthetic replicators, but just basically the idea that these chemicals could replicate themselves, make perfect copies of themselves. And they were based on these dithiol building blocks that form rings, which then stack on top of each other to create, so these rings stack on top of each other to create fibers. And then these break in two, click, and you have two halves. This is an exponentially replicating system, right? You start with one, it breaks in half, then you have two. Then that initial fiber can continue to grow and break in half and grow. And so from 1 to 2 to 4 to 8, 16, you grow. Previous experiments revealed that pre-existing replicators could assist the formation of new replicators in the same flask, which then coexisted and cooperated in each other's formation. And the team set out to see if replicators could evolve if they were given building blocks that were increasingly different in their structure. And so this is when the researchers observed this parasitic behavior that they saw. Replicators comprising 8-membered rings made from a dithiol building block were used to cross-catalyze and assist the formation of new replicators from a second and slightly different dithiol building block in the same flask. And then they saw new 6-ring replicators emerge, and these molecules all by themselves didn't replicate very quickly or very well, but by consuming the 8-ring replicators, they took over the system, which is just fascinating. And I have personally interviewed another researcher named Lee Cronin who has commented on this study. He says, I'm not surprised by this result because computer simulations have predicted such parasitic behavior, but having experimental verification is brilliant because it sets a foundation for an even more exciting set of experiments. The next step would be how the system could self-generate cell walls to confine the replicators, as in biology.
This just sounds like we're slowly degenerating and regenerating the origin of life.
Yeah. And this is, we've talked, a couple of weeks ago when I wasn't here, Justin brought the story about the Mimi virus, or these the giant viruses that are almost like cells. And the question and that question about the that boundary between viruses and life, and what is life and where does life begin? And we've talked previously on the show about the RNA hypothesis of, that the world was initially, life potentially initially started by sequences of RNA,
right,
combining and creating these self-replicating systems. And this is not even as complicated as RNA. These are fairly simple chemical complexes that that easily produce self-replication and this parasitic behavior just based on chemical interactions.
I would be willing to wager that it's all of these things and more that made it all happen.
Yeah.
Honestly, it probably, it was probably all this stuff happening in the soup, right? Working in tandem, coming together and pulling apart, and coming together and pulling apart, that made it all happen. It made it all work. We're seeing bits and pieces, but what we see on its own, it makes more sense if you put them all together, kind of.
Yep. It's beginning to make more sense. And I know there are biophysicists out there who are also working on the physics of life. What are the thermodynamics? If based on the principles of thermodynamics, what led to the complexity of life? What do you need? And so this is getting at the very basic, most basic aspects of the chemical interactions. And so I think there's a lot to explore here, and can't wait to hear more from these researchers and others on this subject.
I remember being a kid in high school and reading in my biology book about the origin of life, and them talking about kind of what was in the soup and some hypotheses as to how that happened, and some lab experiments that kind of sort of worked and gave you an idea of how things could come together potentially. And I remember sitting in class thinking, someday this page will have a real concrete answer on something that has worked and could work and probably did work. And we have these bits and pieces now, but I can't wait until in our biology books, there is just this is how it happened.
Yep. This is how it happened.
It's so exciting. That's my favorite thing about science, is that you can have unknowns and you can have faith that at some point probably we'll figure it out. It's so neat.
We will figure it out eventually. And it's fascinating. Life, from whence came it?
Over there, and over there, and over there, and over there.
Yeah, and following up on this, I have another story kind of related to chemistry and the potential for life. This week, reports from the Cassini mission. People still poring over the data from the Cassini mission, which is now over. There's still lots of data to be looked at. The Cassini space probe at Saturn, it hung out by Enceladus, and we've had news from some of its ventures around Enceladus previously. It flew through some vapor spouts that where this icy watery vapor, gaseous vapor is shot out like a geyser through cracks in the icy surface of Enceladus, the moon of Saturn. And previous research using this data of just looking at the gases and the small components, they were able to show that, in the stuff coming from inside Enceladus was simple organic molecules. There were minerals, molecular hydrogen, and so that there's chemical energy that's in there somewhere. And so this could potentially be like what we see in the hydrothermal vents here on Earth, that maybe the oceans of Enceladus are a life-sustaining broth or soup. But we really still don't have that evidence. But now there's some more evidence. Publishing in Nature this week, researchers have now done further analyses, and they've gotten, instead of just looking at the gases and the water vapor, the vapor coming out of these geysers, they've actually been able to analyze some of the data from ice crystals, like actual little tiny chunks of ice that have come out and that are able to contain larger amounts of molecules and things. And so what they report today is that not just simple organic molecules, but Enceladus's ocean, and it's definitely from the ocean, contains complex organic molecules. Not just simple, but complex organic molecules. And because of the type of molecules that they're seeing, they're guessing that these are coming from some kind of churning at the bottom of the ocean, that there's some kind of geophysical pressures with the crust, Enceladus's crust, that are producing these things. So there's probably substantial heat involved, and that these compounds are then moving through the ocean and up to the surface. And another aspect to some of these is that they are probably floating on the surface of the ocean, even though they come from the bottom of Enceladus's ocean, floating on the surface, and they're hydrophobic, which to me, I mean, that's like, we're starting hydrophobic. That's cell walls. That's kind of important for that kind of thing.
Lipid bilayer. Yeah.
Lipid bilayer, exactly. Maybe there's a membrane in action kind of there. The researchers say this is Nozair Kawaja, who's a researcher at the University of Heidelberg's Institute of Geosciences. He told Gizmodo this is the first ever detection of such a large and complex organic molecules, on an extraterrestrial water world. And so these molecules have molecular masses above 200 atomic units, which is 10 times heavier than methane, which is substantial in order of magnitude. They have aromatic structures, so they're ring-shaped, flat molecules. They have potential cross chains of hydrocarbons, but they don't know whether they are biological or non-biological in origin. And it's hydrophobic, floating on top of the oceans, and it comes from within them. And what are they? What are they doing? This is exciting news.
Let's see. Hydrophobic, complex chains of hydrocarbons. Don't tell the oil companies.
Right. Yeah, at least that. Yeah.
They're like, move all the derricks to Enceladus. Go.
That's right. Yeah. So the potential for life on another planet. I mean, we already are planning missions back to Enceladus. So this gives us even more impetus to do that, to get there and to do some measuring and to find out what's going on in the oceans of Enceladus. So some decade from now, we may have some more results. But for now, oh my goodness, they don't know if it's alive, but maybe.
Well, wouldn't it be great if we just arrived at the exact moment that life began on Enceladus? Then we could watch it happen.
Yeah,
there it is.
Oh my gosh, and just coming off of the last story about these just molecular aspects, kind of capitulating the process of life. You know, it's like, oh, well, if they've got these complex organic molecules, what are they doing and how are they interacting? And are they showing, even if maybe they're not alive yet, is it maybe that premature stage of life developing out of a chemical world?
There you go.
We need to go there. We need to go there. Get us to Enceladus. Do you have any more stories?
I do. I have a great story about a robot bloodhound. Not a trusty furry friend for you, but one that could change the way we do tracking and or search and rescue and or how we are conquered by robots. This is from the American Chemical Society, and researchers have developed a modern day bloodhound that is a robot that can rapidly detect odors from sources on the ground, such as footprints. Most robots can only detect airborne odors as of yet, or they are painstakingly slow at performing analyses of things found on the ground. But this research was based on odor sensor techniques called localized surface plasmon resonance, LSPR, that measures changes in light absorption by gold nanoparticles upon exposure to gas. So the robot could travel across a surface. There was a tube placed on the ground that suctioned in suctioned odors, and the researchers showed that the sensors could accurately detect the location of, in this case, ethanol odor sources placed at different positions along the robot's path at 10 centimeters a second. That's about 4 inches a second. So that's very quick. So it is kind of like a modern day robot bloodhound. So this has potential in multi-robot communication systems. It has potential in security, research and rescue, lots of other things. But this is a robot that could potentially, you could give it the sniff of the shoe that was left behind, and they could chase after someone you're looking for.
That's so cool. The chemical signals.
Yeah.
Sniffing them up.
Sniffing them right up. Speaking of bloodhounds and dogs, the last story I brought tonight is about the Mexican gray wolf, which we were joking about shorts earlier. We did do a short at the San Francisco Zoo about the Mexican gray wolf exhibit that anyone can go to TWIS.org and watch, that has a lot of the long history of the Mexican gray wolf conservation in it. So I won't bore you with all of it right now, but suffice it to say, it is the most endangered canine species in all of the Americas, and it at one point had only 7 individuals. So they have been trying to do a captive breeding program since the 1970s. This is the Mexican gray wolf, Canis lupus bailey. And from that, they have grown the population to close to 300, I think, at this point. There's about 200 in captivity and about 100 in the wild, if memory serves. But the question in this story from Duke University is, are we breeding an actual species? Because since they went down to only about 7 individuals, and they were found in Mexico, Arizona, and New Mexico, and not a huge area, but an area where actually there's quite a few stray dogs, do we have a hybrid species on our hand? In which case, is it going to continually be protected by the Endangered Species Act? Will we be able to do a proper genetic variation of breeding in order to keep this population alive? There's lots of questions from that initial question. Is this a distinct species, or has it been contaminated with Canis familiaris DNA, right?
And so, did they test it?
They sure did. They genotyped 87 Mexican gray wolves. Previously, they had done it on 10 wolves many years ago when the population was much smaller, but now they have a large enough size that they can really do a proper genetic test. So 87 wolves. They found them from a broad spectrum of pedigrees, so they feel like it was a good representation from all 3 original captive lineages. And they also mixed with lineages of wolves born in the wild since release. They use genome edit enabling, which allows researchers to use genomic data from one species, like dogs, to study similar species. So they were looking at domestic dog data, and they looked at average ancestry across the genome. They found that Mexican wolves share an average of 0.06% ancestry with domestic dogs, which at first glance indicates a lack of biologically significant ancestry from domestic dogs. So it looks good so far. So it sounds like they became isolated a long time ago, and they've stayed isolated because 98.9% of Mexican wolf DNA is specific to just Mexican wolves. But they took it a step further, which is why I found this story so interesting. They said that they wanted to see if some of the dog stuff in there, they wanted to see if it was artifacts or if it was directly from some recent inbreeding, even if it was in only 1 or 2 cases. So they did simulations. They did computer simulations of what the Mexican wolf genome would look like if no hybridization took place, if hybridization with domestic dogs occurred 2 generations ago, 20 generations ago, or 200 generations ago. And when they matched that against what they found in the 87 samples that they collected, they found that the Mexican gray wolf data matched the predictive model for no hybridization. So they now know with pretty good certainty that the Mexican gray wolf is a distinct subspecies. And the good thing is there's actual implications from that. Guaranteed funding and protection, continued success in their breeding programs. There's all sorts of things that come from just being sure that you're not dealing with dog contaminated lineage. So there's
not
the
contaminated with dog.
There's also the biological stuff. So it's really cool. We now know for sure that this species that we brought back from the brink of extinction, never mind that we put it there, but we brought it back from the brink of extinction, only 7 individuals at one point, and we are continuing to see a pretty healthy genetic population. We know not to mix in dog DNA because we haven't done it before, and we're going to continue on with the processes we've had, and hopefully we'll see this species make a full recovery. Who knows?
Which would be fantastic. But again, this gets at that question of, okay, what is a species? Because this is a subspecies.
This is a subspecies, yes.
Right. So it's, it's got its own quirks genetically, but it is related to the general gray wolf, right?
Right. Yes.
Genome. And then we know dogs come from wolves. So, it's all blended at some point. And you've talked specifically before about, it's great to save species, but what about ecosystems? What about, not just one species? What about the habitat?
Right. Absolutely. So unfortunately, the way this land of ours government works, species become protected more often than spaces. But if you can currently in the framework we have, if you can protect enough species native to an area, that area will find protection and other species in that area will benefit from it, which we've reported on the show as well. But in the case of the Mexican gray wolf, it's kind of worked the other way, which is why the Mexican gray wolf story has been so successful. Is they started when they first pulled the 7 individuals. They started establishing wild lands for reintroduction later, which is why this has had such success to this point, is that they have been releasing these animals into spaces that have already been established as wild spaces and protected spaces. So in this case, because it's also in an area where there are wild spaces for them to go, that's actually been really successful. But it's a really good question to ask. If we're going to save a species, is it truly a species? Is it savable? And is there space for it to go? Right? So food for thought.
It is food for thought. But can't we all just get along? Can't we just protect everything? Can't we sustain our environment and this planet that we live on and the wonderful abundance of all the different varieties of life that are extant upon it?
Yes, but
I
you
am an
have to give up
idealist. I
some
know,
creature
I know.
comforts, which some
I
people
know,
are
I
not
know.
willing to do.
Compromises. Like in Canada, some Canadian festival goers are not able to go to a blues fest music festival because of one little killdeer. That's right. In Canada, the killdeer is on the list of protected species, and there is one mother, and she has 4 eggs that were discovered on one of the festivals that were discovered while they were setting up one of the festival's main stages. So no
Oh my
festival
gosh.
because of one bird.
Oh
Brilliant.
no. Oh,
Sorry, Blues Fest lovers.
I feel like that gives environmentalism a bad name sometimes and stuff like that.
Yeah. Yeah, but, you gotta. The law's the law, people.
Ah.
I had another robot related story. You had your robot Bloodhound. Well, I've got a beaver bot. It's not really a beaver. It's not really a beaver bot, but this robot is an autonomous robot. It's been developed by an assistant professor of computer science and engineering at the University of Buffalo's School of Engineering and Applied Sciences, Nils Knapp. He says, when a beaver builds a dam, it's not following a blueprint. Instead, it's reacting to moving water. It's trying to stop the water from flowing. We're developing a system for autonomous robots to behave similarly. The robot continuously monitors and modifies its terrain to make it more mobile. And what they are presenting is this robot who can kind of hang out in, any terrain and use aspects of the terrain to be able to navigate that terrain more efficiently. And the robot in question here is capable of picking up in their test situation, picking up bean bags and moving them around its environment to create a platform or a ramp that allows the robot to move around. And so, whereas it might be difficult in, say, a disaster situation where there's a landslide or whether there's been an earthquake or something where there's rubble strewn around, this robot could then take objects in the environment to create something more suitable for it to navigate, to be able to drive around on, all by itself.
Wow.
Yeah. Doesn't look like a beaver. It looks like a little remote control car, but it's not remote control. It does this by itself.
I feel like they need to put a flat tail on the back of it.
Yeah. They could. They could put a little flat tail, like a little beaver tail on the back of the
Yeah.
And then it would really be a beaver bot. Yes. Which I love it. Robots, they're going to be helping us out, taking over our environment, building dams. No, not maybe building dams. I don't know. We'll see. And then another, I'm getting into my last minute kind of quick stories here. Researchers at MIT have been working with a company in a group in India to create a new prosthetic foot. And so this in 2012, there's a researcher named, what is his name? Amos Winter. He is an associate professor of mechanical engineering at MIT. He was approached by a group called Jaipur Foot, and they are a manufacturer of artificial limbs in India. They have a passive prosthetic foot that is aimed toward amputees in developing countries. And so this is something they're trying to make low cost and turn out lots and lots and lots of them. However, they are right now, these prostheses are not low cost. And these individuals so far, Winter says of the design they had previously, says they've been making this foot for over 40 years. It's rugged, so farmers can use it barefoot outdoors. It's relatively lifelike. So if people go in a mosque and want to pray barefoot, they're likely not to be stigmatized, but it's quite heavy. And the internal structure is made all by hand, which creates a big variation in product quality. And so the researchers trying to figure out if they could make a better, lighter, easier to produce foot that would allow natural movement. And so they started looking at how they could design this thing and decided that what they needed to do is not necessarily design the foot movement itself, but how the lower, they wanted to create the most effective lower leg swing, because it's really that swing of the lower leg. If you've got a prosthetic device that's from the knee down, it's the swing of the leg that really affects the gait and the walking ability. And so they've come up with what is now a very low cost, easy to produce device that allows a fairly regular walking gait, and people are able to walk very easily wearing it. And the kicker to this is that it can, this can be mass produced, and where the prosthetics from at one point were, $1,000 to $10,000 to produce, the ones that they are going to be mass producing would be, under $100. These would be minimal cost.
That's great. I mean, they're not even really limping in the video.
No, yeah, there's a video of a gentleman walking with wearing this prosthesis, and he's got a very natural gait, and he seems to be very happy with the flow of his movement.
Yeah. Wow, what a relief.
Yeah,
I'd imagine.
And this is extremely exciting because of the potential effect for developing countries. Not just here in the first world, in the United States, in Europe, whatever, but in developing countries, to enable people to continue their livelihoods with more ease. It's so this is a pretty cool development that could have
Very
some
cool.
huge impact. And they used some very okay, so I said it under $100, but it would be just a few $100s. So instead of $1,000 to $10,000, it would be a few $100s. I just want to make sure I'm accurate on what I'm reporting there.
Well, and the more made, if there's mass production involved, that would drive down cost also. So
yep,
it's definitely nice.
Very nice, right? Very exciting. Yeah, I had a story for Justin, but he's not here. He used to get very excited about Hayabusa, the Japanese spacecraft that was going to go on a return mission to an asteroid. Well, Japan has sent out Hayabusa 2. Hayabusa 2. And Hayabusa 2 is in orbit. It has inserted into orbit around another asteroid. This is a second craft around a different asteroid. And this asteroid looks kind of like a cube or a dice. And there is going to be, I'm sure, a lot of information coming from this asteroid after Hayabusa lands on it and sticks it and gets a sample and then flies back home to return a sample from an asteroid to our planet. Learning more about the asteroids in our solar system. The Japanese are on the forefront of this. Very cool.
Very neat. It is oddly cube-shaped.
Yeah. It looks a little dusty, and it's got, kind of rocky surface, but yeah, it is quite cube-shaped.
Yeah.
What forces would lead to a cubist asteroid? I have no idea. We'll have to find out.
Yeah. Maybe it'll tell us.
Maybe we will find out something soon. Yes. Oh, and also big news of today or this week, the James Webb Space Telescope has been delayed again. So now it's not going to be launching until March of 2021. It was looking at a 2020 launch. Originally, it was this year, and then 2019 and 2020 and 2021. We're okay. And because the James Webb Space Telescope isn't going to be launched and it isn't ready to go, they're considering cutting back on the successor, the program for the successor to the James Webb Space Telescope, the WFIRST space telescope, which they're already starting planning on. They're talking about cutting funding to that one. And I mean, it's like, if you don't have the Webb out, why are we talking about its successor?
Yeah,
So
that's a good point. But also, for the amount of money these things cost,
billions.
do it right the first time.
Billions. Yeah. No,
Be late and do it right.
Yeah, and part of the problem with the James Webb is it's going, you're going to launch it out to this space, space in space, a dwell point where it's going to be very far from the Earth. It has to be in a very cold location for its infrared viewing of the universe, and it's going to go out there and it's going to deploy. And if anything goes wrong, there's no International Space Station to go and fix it. There's, the mission to go and fix it is going. It's not going to happen. So you don't want to send something out there after spending years and years and billions of dollars to just be space junk. And so they have to get it right.
Yeah.
They got it. Just at this point, we've gone so far. We need to just do it. Just can I have my James Webb Space Telescope already? Please. Come on. I want some pretty pictures from outer space.
Oh, you'll get your pretty pictures.
You'll get your pretty pictures, my pretty. Yeah. Is that it?
I think we did it.
Do it. Yay! We have done it. Thank you, everyone, for joining us once again for this episode of This Week in Science. Wonderful to have you here with us. Thanks to everyone in our chat room who are watching live on twis.org/live. Everyone watching live over on YouTube and other places. Thank you for joining us this evening. And for those of you who are out there listening, wherever you are, watching, wherever you are, thank you for sharing us with your life, bringing us into your life. I'd like to thank Fada for helping out with show notes and also with social media posts. He does a great job on that. And I'd like to thank Identity4 for recording the show and Brandon for helping simulcast to Facebook. And it is time for me now to thank also our Patreon sponsors. Thank you to Paul Disney, G. Burton Lattimore, Richard Onimus, Ken Hayes, Harrison Prather, Charlene Henry, Joshua Fury, Andy Gross, Steve DeBell, Alex Wilson, Tony Steele, Ed Dyer, Craig Landon, John Ratnaswamy, Mark Massaros, Jack, Matthew Litwin, Jason Roberts, Bill K, Bob Calder, Time Jumper 319, Kyle Washington, Eric Knapp, Richard Brian Condren, Aiden Jeff, Kevin Reardon, Dave Neighbor, Christoph Zukniarek, Noah Zemke, Jim Seabright, Ashish Pants, Jacqueline Boyster, Ulysses Adkins, Sarah Chavez, Richard Porter, Artyom, Rick Ramus, Paul, John McKee, Jason Olds, Brian Carrington, Christopher Dreyer, Lisa Slazewski, Jim Drapeau, Greg Riley, Sean Lamb, Ben Rothig, Steve Lessaman, Kurt Larson, Robert Aston, Rudy Garcia, Marjorie, Gary S., Robert, Greg Briggs, Brendan Minish, Christopher Rappin, Flying Out, Aaron Luthen, Matt Sutter, Mark Hessenflow, Kevin Parrish, and Byron Lee, E.O. Mark, Tyrone Fong, and Keith Corsell. Thank you for thank you for your support on Patreon. We do appreciate your help. And for anyone interested in how they can help us out, you can find information at patreon.com/thisweekinscience, or you can help us out by telling your friends about TWIS. Yes, on next week's show. Oh, it's going to be the 4th of July. Which is a holiday, and I don't know if there's going to be a show next week. Blair, is there going to be a show next week? We haven't talked to Justin because Justin's not here.
It sounds like probably not a good idea. I mean, I feel like the sound quality would be great anyway because you'd hear in the background the whole time.
Fireworks everywhere.
It's everywhere.
Oh, my goodness. Yeah, we'll figure something out. But we like to. I got to edit a whole bunch of things out here for the podcast. We broadcast live online, 8 p.m. Pacific time on twis.org/live on Wednesdays, where you can watch and join our chat room live. But don't worry if you can't make it, because you can find our past episodes at twis.org/YouTube or at twis.org.
Thanks, everyone, for listening. We hope you enjoyed the show. TWIS is also available as a podcast. You can search for This Week in Science in the iTunes situation, or if you have a mobile device, you can look for TWIS, the number 4 Droid, which is an app in the Android marketplace, or you can just search This Week in Science in any of your Apple devices.
That's right. And for more information on anything you've heard here today, show notes will be available on TWIS.org, our website, where you can also make comments and start conversations with the hosts and other listeners. You can also do that at facebook.com/thisweekinscience.
Or you can also contact us directly. You can email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in your subject line, or your email will be spam filtered into oblivion.
Pew, 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 pew.
You can also hit us up on Twitter, where we are at TWIS Science. That's with one S. At Dr. Kiki, at Jackson Fly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, something that you wanted us to see, dog videos, lots of people send me those. Just go ahead and let us know.
Just go ahead. Let us know. We will be back here next week, and we hope that you'll join us again for more great science news.
And if you've learned absolutely anything from the show tonight, remember,
it's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say, and if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 This Week in 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 Science.
That was a Dr. Kiki sing-along video. It's the end of the show. It's time for us to go. Hot Rod wants to know if we're having an after show. This is the after show. For all I know. Yeah. Interest. You're funny, Hot Rod. Funny, Hot Rod. Yeah, TWIS-of-July. We got to have a TWIS-of-July. I was trying to talk Blair and others into maybe recording an episode earlier in the day, but Blair has to work.
I have to work.
He has
I'm
to work.
expecting 8 teenagers. It's less than my usual 12, but 8 of them are still coming.
Because animals still live at the zoo even though it's a national holiday.
Yeah, and people come to the zoo even more on national holidays, you see. But also,
Yes.
I think a lot of teenagers' parents want them to go to the zoo so that their parents can have an adult barbecue without them. That's my guess. They're like,
probably true.
oh, sweetie, you have to work? Oh, shucks.
Oh, you just go to work.
I'm just going to have Aunt Margaret over without, you won't be able to hang out with us. What a shame.
Bye, Gerald Sorrells. Who else was there? Stars, Nova, Science, and Astronomy. We've got Blue Streak Science. We've got Carrie Rootens wants us to have a different term instead of talking about the primordial soup or broth. He says that implies somebody's eating it. So can we have a not food related term?
Yes, the primordial cesspool. Is that better?
There we go. The primordial ooze.
The primordial U-bend.
Ew. Yeah. I'm back. And I'm tired and my head hurts. Why does my head hurt? It just started hurting like halfway through the show. Sometimes I think that these earbud headphones, that they exert a pressure on my ear canals or my ear on the, and just push, and I don't think they fit my ears very well, and then maybe that makes me have a headache.
Yeah, that could be it.
I don't know.
My headache today, I'm sure, is from the change in barometric pressure.
It's very possible.
Because it was like, I don't know if you can tell, I'm in a sweater today.
It sounds like summer in San Francisco.
Yep. Indeed. And I was in 97-degree weather all weekend. So
there you go. Yeah.
It's quite the drastic change.
We had a storm come in here today, and there was quite a temperature drop this evening as well. Yep. Yeah, Ed from Connecticut is going to be ready to take a long nap after the 4th of July feast. Do people have plans for 4th of July? Yeah, Noodles says grill and drink.
I'll be chilling with some guinea pigs.
You're gonna have the guinea pigs. Yeah, we were invited to somebody's 4th of July party. I'm gonna go do fireworks in a parking lot.
Yeah.
Barbecue and set off fireworks in a parking lot. That sounds like the quintessential 4th of July experience.
I think I'll have front row seats to all of the fireworks in the city because of that.
That's cool.
House. You know how it is.
That's right. Yeah, that's right. The tree house. They're in Barcelona right now, huh?
Yeah.
But here in Portland, and this is something for an Identity 4, you're in Seattle, which is like another 4 hours north of us here. I am amazed at how late fireworks have to start. You can't really have the fireworks until it gets dark. 4th of July is very shortly past the summer solstice, so we're still dealing with nights in which it doesn't get dark until 9:30, 10 o'clock at night. So you can't start the fireworks until like 9:30, 10 o'clock at night. It's so late. And I want to go see the fireworks, but then I've got my 7-year-old who's supposed to go to camp the next day. And he won't be in bed until like 11 o'clock, maybe. I mean, that's living in a northern place. Yes, going to work the next day. Exactly. Like, I think we should have the 4th and 5th of July.
Or just the 5th, because people do stuff at night, right?
Right. Or yeah, exactly. Just the 5th. So you could get off work, go do fireworks and a barbecue, and then take the next day off, because it's like, yeah, I got a holiday, but it made me stay up late. And then I'm tired the next day. What?
Yeah, it should be like New Year's Day, right? Like everyone goes out on New Year's Eve, and then you have New Year's Day off.
Right. Exactly.
Like I don't get New Year's Eve, but I do get New Year's Day off.
New Year's Day. Because I don't care about New Year's Eve until the nighttime.
Yeah.
And then the next day.
There you go.
I was up until 1 a.m. It's time to go to bed. I'm tired.
1. Yeah.
I'm making myself sound a little bit.
Yeah. I was up till 12:08 last night. I'm tired.
So tired. Oh my goodness. Yes. Yeah. Yeah. Identity Force is going to be rough for people who have to go to work the next day. It will be. Well, everyone out there. Oh, and you think Identity Force has to work on 4th of July?
Yeah.
We could work. We could do a show. Could send my family off to launch firework things in a parking lot. That doesn't sound like fun.
No.
Come on.
Enjoy your independence while you have it.
God. Independence Day. We're going to do it. Yeah. July 1st is Canada Day. That's right. Our northern neighbors are going to have a good day. July 1st. Yeah. Fun stuff. But I have to talk. Justin hasn't responded to the question. So
he's probably asleep.
He's probably asleep. So this is something I was going to talk with you both about on the show tonight, but he's not here. So I don't know. Maybe I'll because Justin's not here this week, maybe I will let him do the show by himself next week.
Yeah, just him. Yeah.
Just him by himself. There will be no music, and there will be a very long dialogue about what do you think he'll rant about?
Oh, politics, probably.
Politics, yes, not science, but politics. Politics, yes. Talk about that woman and the kids. Suzako 23, I don't know what you're talking about. I don't have a story about any women and children. Suzako 23 is referring to something of which I do not know. Identity 4, you're on a hill, so you can watch all the fireworks between home. Oh, awesome. From your window, that's perfect.
Yeah.
Absolutely perfect. That sounds lovely. That sounds optimal. Yeah. I live in a flat area. I need to go somewhere and go up on top of a hill to see the fireworks. Yes. And to everyone, another reminder, dog owners, pet owners, keep your animals indoors on the 4th of July and all the days surrounding it, because people get fireworks and decide that they're going to set them off at
do a practice run
all hours. Yeah. So, yeah. And people with PTSD, please keep your therapist's phone numbers handy and your anti-anxiety medications handy. And maybe also stay indoors and with your head under a pillow.
You know what they invented that I kind of want is a weighted blanket. It's like a thunder vest for dogs, but for humans. And I just love the weight of blankets on me. So I'll have a million blankets on my bed just because I really like the feeling. And so I saw that, I was like, oh, that might be perfect for me. but really it's for that. It's for people who need the extra comfort. So pretty cool.
You can spend a lot of money on a weighted blanket, or you can just put a lot of blankets on
Yeah.
top of you.
Yeah. I guess the benefit of the weighted blanket is that if it's not
It's not as hot, maybe.
Yeah, it's not as heavy. It's not as hot. Exactly. Yeah.
Yeah, gravity blanket. That's right. Noodles.
Mm-hmm.
The gravity blanket. They're expensive.
Mm-hmm. They are. I'm waiting for them to be cheaper.
I know. My husband wanted to get one, and I just looked at him like, what?
Yeah.
I was like, no.
Yeah. Buy some chainmail, why don't you?
Yeah. We can go to the hardware store and or we can go to the garden store, get some rocks.
Yeah.
I'll sew them into a blanket for you.
Uh-huh. Yep. There you go. Yeah.
Yeah. How about here's a new thing. While you're sleeping, I will come because I come in from doing This Week in Science on Wednesday evenings, and he's usually already asleep because he's put Kai to bed. I'll just come in when I get off the show and just put rocks on him.
Yeah, there you go.
I'll just keep rocks handy and just put rocks on top of him in the middle of the night. Bags of rocks.
Mm-hmm. That's good.
Take your gravity blanket and raise you a bag of rocks.
Or just like sleep directly on top of him. Like, here's my entire body weight. How's that?
That's right. I'm comforting, aren't I?
Yeah. You're like, you're lumpy. What's this bony elbow doing here?
But you know, if I did that, I'd be like, Kiki smash, and I'd go all Hulk on him,
Yeah, of course. Oh, you'd have to do a running jump to do it.
Kiki smash.
Gentle. Yeah. Yeah. If you're gonna do it, you got to do it right.
He'll be like, "What? I was sleeping. Why are you doing this?"
You're like, gravity blanket.
Woo. Oh, it's going to be awesome. Little does he know what's in store for him tonight.
Oh my God. You have to tweet out the results so we know what happened.
Oh my God. I win.
Yeah.
Hulk Kiki always wins.
There you go.
You don't need a blanket. I need a blanket. I like blankets. They're fantastic.
I love blankets.
Is there anything? Let's see. We're getting into July. I don't think. Yeah. So 4th of July was the thing that I wanted to talk about. I can't. Yeah. A TWIS fireworks. Those would be awesome. I like that idea. TWIS fireworks. That's right. This Week in Science. Fireworks. Use them safely. Safety third.
Safety third. What's 1 and 2? Fun.
Right.
And
learning. Safety.
Sure. And then safety.
Danger, excitement, adventure.
Yeah, I mean,
now
that's how you learn.
Now we're getting into safety like 7th.
Oh no.
Coming up with too many things.
Yeah.
Yeah, I made fireworks once. I made sparklers. They worked okay. They weren't great, but they worked okay. But I'm probably on a list from the government somewhere because I ordered fireworks making chemicals.
Right. Yes. Luckily, you have many items of proof showing you are a science person.
I do science. Come on.
That's like, what does this person need with 5 pounds of fertilizer? Oh, they have a gardening blog. Okay, it's fine.
Right. Oh, there was something recently. UC Davis, nitrogen in rocks. There was something recently, some big discovery about nitrogen. I forget what it is. But anyway, speaking of fertilizer, nitrogen, it's important. Yeah. No, I'm tired and I have a headache and I don't know why I do. And I think I should probably go to bed, even though I had a cup of black tea before the
no!
show because I was tired. It's a never ending cycle.
Well, I bid you adieu to lay back in bed with your eyes wide open, staring at the ceiling for the next several hours. Do enjoy.
Maybe I get ibuprofen or something. Maybe it'll all be better when I take these earphones out of my ears.
Ibuprofen PM would recommend. For headaches, because headaches keep me awake sometimes. So if I have a really bad headache and all I need is sleep, I will occasionally pop a ibuprofen PM.
Yep. Mama said knock you out.
Use as directed, everyone.
I'm gonna knock me out. Yes. What did Identity 4 post a picture? Oh, that's beautiful. Mount Rainier. That's gorgeous. A pretty mountain. You have a great view, Identity 4.
Whoa, no way.
That's gorgeous. Yeah.
You've probably been in that apartment forever, which means it's normally priced.
Thanks for sharing that. That's pretty. Chat room. Yeah. Yeah. Okay. You're welcome for the show tonight, everyone out there. Hi, chat room. Yeah. Thank you for being here with us. And yeah, time for bed. Good night, Kiki.
Oh, yeah. Say goodnight, Kiki.
Good night, Kiki. Say good night, Blair.
Good night, Blair.
And
good night, minions.
Minions.
Yeah.
Everyone out there. Good night, nobody. Thanks for watching and enjoy the 4th of July if we do not have a show next week. And I hope everyone is well and good science to you all. See you soon.
Good night.